Imagine scrolling through your feed and hitting a video that forces you to stop and watch. You might assume you chose to stay, but Meta recently built an AI that predicts that exact neural reaction before you even see the thumbnail. For years, measuring human attention meant waiting for the data to roll in. Engineers relied on trailing digital analytics, counting clicks, measuring watch time, and tracking scroll depth after the fact to guess what kept you engaged. It was an indirect science, reacting to your behavior rather than forecasting it. Neuroscience took the opposite approach. To get real data, researchers physically loaded individuals into massive, expensive MRI scanners, attempting to map their real-time neural responses to specific images and sounds as they happened. Both of those methods are rapidly becoming secondary. Meta's researchers recently unveiled TribeV2, the Trimodal Brain Encoder. This system acts as a high-fidelity digital twin of human neural processing.
It predicts exactly which parts of your brain will activate when you see, hear, or read something, and it does so with a 70 times higher resolution than any previous model. This removes the physical requirement for mind reading. A simulation can now replicate a human's biological reaction with the same level of detail once provided by an MRI. To build this simulation, Meta's researchers fed the AI over 1,000 hours of actual human brain scans. They tracked the neural activity of over 700 volunteers as they sat inside machines, actively watching movies and listening to podcasts. To connect this biological data to the digital world, the system requires an architecture capable of translating between two completely different languages. It must link the physical blood flow recorded in these brain scans to the precise pixels and sound waves volunteers absorbed at that exact millisecond. It achieves this by using the large language model Llama 3.2 to translate and comprehend all the text and spoken audio inputs from the media. At the exact same time, a vision model called VJEPA2 processes the incoming video frames. The AI merges these visual, auditory, and text inputs, mapping the combined stimuli directly to the corresponding neural activations recorded in the human volunteers. TribeV2 is doing something different than standard content algorithms. It actively reverse engineers human perception, turning biological reactions into actionable digital code. The system relies on a machine learning concept called zero-shot generalization, which occurs when an AI performs a task it hasn't been explicitly trained to do. Because TribeV2 ingested such a massive, diverse baseline of training data, it has mapped the neural commonalities we all share. It does not require a scan of your specific brain to understand how you will react to a new stimulus. It can predict a typical human brain's response to entirely novel, unseen content more accurately than taking a real-life scan of a single person. Researchers can feed the AI a new video, and it instantly outputs predicted neural activations without needing a physical human subject in the real world. By achieving this, the AI has successfully modeled the universal, shared baseline of human attention. This shifts the core methodology of neuroscience. Scientists can transition from physical subjects to in silico or virtual brain experiments run entirely on a server. This compresses the timeline of research. Studies that used to require months of recruiting patients, booking MRI time, and running physical lab tests can be executed in seconds of digital simulation. Accelerating the testing phase allows researchers to rapidly iterate on treatments for complex neurological disorders like Alzheimer's or Parkinson's. It functions as a precision instrument, allowing researchers to refine neurological treatments without requiring a patient to undergo an invasive procedure. But there is a secondary application for this tech. This is the start of computational neuromarketing, driven by massive tech entities. Corporations can now A/B test their app interfaces and video designs using these simulated brains. Instead of testing on live focus groups, they can test thousands of variations in minutes to see exactly which colors or pacing trigger the strongest bursts of activity in human reward centers. This enables what experts call neuro-hijacking. If an algorithm knows exactly which visual patterns trigger your brain's reward centers, it can iteratively refine content until it generates a near-constant release of dopamine.
This creates a feedback loop where the biological impulse to keep scrolling overrides the conscious intent to stop. Meta has chosen to open source the model, releasing the Tribe V2 technology for independent researchers and private companies to use at will. The digital twin changes the nature of mental privacy. An entity no longer needs to scan your actual skull to know your thoughts. They only need a sufficiently accurate model of your neural processing. As this technology scales, we are left with a choice. Tribe V2 can either be used to help heal the human mind or to exploit the biological impulses that govern it.